Alright, hey, welcome to 4.3 example A, and it says, describe how the graph of f of x equals 4 plus 2 parentheses x minus 3 is the translation of the graph f of x equals 2x. Alright, so what we're going to do is let's take a look at these graphs first, okay? So what we have here is this blue one is the just f of x equals 2x, alright? And the red one is the f of x equals, or I should say f of x, but the 4 plus 2x minus 3, alright? So we're really going from the point 0, 0, and we're saying that point 3, 4 is on this red line, right? So we're really moving up to here. We're taking this point and we're translating it up to this point, right? So really we're going to the right 3, and we're going up 4, okay? So what we can do is let's replace the x here with the x minus 3, and then we have to add 4 at the end. Okay, so what we could really say is this graph could really just be f of, let's just even say y equals f of x minus 3 plus 4. So that means it shifted to the right 3 and it went up 4. Okay, and that's really what we're looking for here. Okay, so another thing we could do is kind of say, well, we could go right 4 up 3. Right 3 up 4, sorry. And some people have kind of looked at Bellringer maybe and said, oh, you know what, maybe I can also do some distributive property here. So if we kind of rewrite that one as saying, let's, instead of calling this one f of x, let's call it g of x. That way we don't get confused. Let's just say this one is g of x equals, and I've got the 4 plus, and I'm going to distribute the 2. So I've got 2x, and then 2 times negative 3 is minus 6. So then I can kind of rewrite that as 2x minus 2. So if we look at this, that would also mean saying that we could also say, look, I think it just moves down 2. So if we look at this graph, is it also saying we've just moved down 1, 2? Sure, because it went from 0, 0 to 0, negative 2. So we could also say this graph moves down 2. It kind of does the same thing. All right, so those are equivalent graphs. So now let's move on to example B here. Alright, so example B says the red graph is a translation of the function f. Write an equation of the red function in terms of f of x. There we go, now we can see it all. Okay, so we see this red one here, and you may not be able to have the colors on there because we couldn't print in color, but you can see the red one is the one that's down here, okay? So in case you were wondering, you might just want to label this one as the red one. Okay, so the red graph is a translation of the function f. So this one is our f of x. We want to be able to write the equation for this one. Well, we don't know what the equation is, but we know it's the exact same thing as this f of x. It's just kind of translated down and over. So we have to say how many down, how many over. So what I could do is I could say this point here matches up with this point here. Right? So how many down do I have to go? I went down 1, 2, 3. And then we can go to the right, 1, 2. So we could probably just even write this as we're going down 3 and right 2. Okay, so then if you can kind of remember, well, what is that going to look like? Well, we could say this new red function is going to be whatever we had from before, this f. Right, but if it's going to the right 2, we're going to say x minus 2. And if it says down 3, I'm going to say minus 3. And that would be the equation, right? Just take whatever we had and say, I went down 3, right 2. Now I just checked this one point. Is that going to be the same for this point to this point? Do I go down 1, 2, 3, right 1, 2? Yep. Could I go the same for this one? Down 1, 2, 3, right 1, 2 goes to here, and down 1, 2, 3, right 2 goes to here. So all of them seem to match up going that down 3, right 2, down 3, right 2, down 3, right 2. Now I just picked kind of these changes in where the graph is. I could pick any point and see if that matches up. I just happen to pick ones that are kind of easy to see and recognize. Alright, so there's your 2 examples.